Okay, so they give us 3 plus 2i. They give you 1 0 here. Oops, that was terrible. 3 plus 2i. Okay, so they give you a 0. They give you some zeros, but they don't give you all the zeros, okay? In this case, they only gave you 1 0, but they say it's degree 2. Degree 2, okay? So what you need to understand is this. If you remember, imaginary answers always came in pairs, okay? They come in conjugate pairs. In case you guys forgot what conjugates are, conjugates are almost like opposites. If I gave you negative 3 plus 4i, the opposite of negative 3 plus 4i is positive 3 minus 4i. That's the opposite. Conjugate, you don't change everything. Do you remember what you change? Just the one in the middle, negative 3 minus 4i. Okay? You don't change everything, just change the one in between them. Okay? So, they told you 3 plus 2i is a 0, right? So what's the other 0 that they don't tell you? 3 minus 2i is the other one. Is that all of the zeros? You got to look at your paper in order to answer this. Is that all the zeros? Yes, why? Second degree. Okay, second degree. So, those are my zeros. We need to come up with a polynomial. Okay? So, let's do this. Let's work in reverse here. If I told you my zeros are, let's look at it like this. The zeros are negative 4 and 2. Then the factors would be x plus 4 and x take away 2. Okay? So when you have its factors, you got to have it start off with an x. Okay? So my factors are going to be x, and then you put the opposite of all of this. Okay? So what's the opposite of 3 plus 2i? I'll say this, negative 3 minus 2i. And then over here, our factor is going to be x, then put the opposite. We're going to put minus 3 plus 2i. Okay? The first 1 or 2 questions, we're going to do this the long way. Then we'll show you a little shortcut that you can do. You don't have to do the shortcut, but it's kind of nice because you're going to do it's going to get kind of in depth here, and then you're going to go, oh man, it's a mess. But if you follow the shortcut, it's really not that bad. Okay? So, we need to multiply everything by everything. So we're going to multiply each of these 3 first by x, then later on each of these by negative 3, and later on each of these by positive 2i. I'm sorry, negative 2i. Okay, so let's start with x. X times x is x squared. X times negative 3 is negative 3x. X times 2i, you can either say 2ix or 2xi, it doesn't matter. I'm going to say 2ix plus 2ix. I'm going to put my i's before my, I'm going to put them alphabetical. Even though I is not a variable, I is a number. Okay. Now we're going to times by negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. And negative 3 times 2i is negative 6i. Okay. Now we got to distribute the negative 2i. Negative 2i times x is negative 2ix. Negative 2i times negative 3 is a positive 6i. Negative 2i times positive 2i is a negative 4i squared. Now that's a mess, but it's going to get nicer real quick here, okay? Let's combine like terms. What can I put with x squared? Absolutely nothing. What can I put with negative 3x? 3x, is that it? Negative 6x. What can I put with 2ix? Negative 2ix, and what's that? Now be careful on this one. What is I? You guys remember what I squared is? Negative 1, which changes this negative 4 into what? I'm going to make it positive 4. That's a positive 4. Okay? So what can I put that positive 4 with? 9 and 4. I squared is negative 1. Negative 1 times negative 4 is positive 4. And I can put 6i and negative 6i together, and that's gone. And we're done, other than c plus f of x. Now, this problem's done. Don't do any more writing for it, okay? And we did more writing than what's necessary. We're going to do one more problem the long way, and then we'll see if you guys can find the shortcut. This is second degree. How many places does it touch the x-axis? Huh? not twice. It doesn't. Why? They're both imaginary. Okay, it doesn't touch the x-axis. Okay, it never touches the x-axis. Okay? All right, number 3. All right, so this degree 3, they give us 2 and -2 minus 5i. Now they give you 2 zeros. It's degree 3. Okay, it's degree 3. All right? So what's the other 0? Remember, if 2 is a 0, is -2 also a 0? Does it have to be or not? If 2 is a 0? No, what did we say come in pairs? All zeros do? No, which ones always come in pairs? Imaginary ones, and 2's not imaginary. Okay? This one's imaginary. So if -2 minus 5i is a 0, what's the other 0 that they didn't tell us about? -2 plus 5i. Okay? So, let's write our factors. If -2 is a 0, put x minus 2. Our next 0 is -2 minus 5i. We're going to say this real slow, okay? We're going to put x and then minus all of that. So x minus -2. So what am I going to write? Plus 2. And minus 5i. And plus 5i. Then do the same thing on the last one. Put x. For factors, you always start with an x. And it's going to be minus each of these. So minus 2, again, is plus 2. And then minus 5i. I haven't said this year. I've said it last year several times. So how do I multiply 3 things together at the same time?
Yeah.
You can't. Now, I'm going to throw it out here and see if anybody can see what the shortcut is. Instead of doing all this writing here, there's a little bit, yes, sir.
Can you cross out both 5i's?
No, you still have to times it out, okay? What I'm saying, though, is you got to look back here. You got to remember what we did about 5 minutes or so ago. You don't need to write everything out, okay? Anybody think they know what you don't have to necessarily write out when we're doing this?
I feel like we did this last year.
No, we didn't. We didn't do this last year. Let's do this. Even though these are the messy ones, the ones that are most alike, the ones with the imaginary numbers, you want to do those first, okay? Here's the deal. I'm just going to go and tell you, okay? Any term that has just, when you times them, when you FOIL this out, when you multiply this out, any term that has just an I in it, you don't need to write it out. Why? Because they cancel. They cancel. Just an I. Was this one necessary to write out? Yes, because why? It's an I squared. Okay, I didn't need to write out this 2ix because later on I know there's going to be a -2ix. This -6i. So if it has just an I, if you want to write it out, go ahead. But it's going to cancel. It's going to cancel. Okay. But I'm lazy. Anytime I see just an I, I'm not going to write it down. So let's start with x. X times x. Am I going to write down x squared? Why?
It's x squared.
What am I not going to write down? Things that have what? Just an I. I didn't even say I. So x squared. X times 2. Am I going to write that down? Sure, it's 2x. X times -5i. Because what is x times -5i? -20i. I don't need to write that down because eventually we're going to come across what? A positive 20i. We will. When you times conjugates, the i's are going to, when you times conjugates, the i's will all go away. And they did go away. Okay? So I'm not going to write that down. X times -5i. If you want to write it, go ahead. I'm not. Start with 2. 2 times x, 2x. Write it down. 2 times 2, positive 4. Write it down. 2 times -5i. We're going to write that down? Nope, it has just an I. There's our other, that's our -10i that we were said was going to eventually cancel, okay? Now do we even need to bother timesing by 5i then? Yes, we do. Yes, we do. Here's why. 5i times x, do I need to write that down? Mm-mm. It says just I. Well, ix, okay? We don't need to write down 5ix. Do I need to write out 5i times 2? No, because that's going to be 10i. Do I need to write down 5i times -5i? Because you get -25i squared. What I'm saying is any term that has just an I. I mean, if you have an xi, that's okay too. Okay? But we have -25i squared. I would think the rest of this you can do in your head. X squared, then what? Plus
4x.
4x, plus what?